Hi, this is Ken Nixon, and I'm doing a follow-up video for a YouTube picking channel, lock picking by Correct Genes. He picked my 91B padlock, which is what you see there, and there's a video link. So if you haven't already seen this video, you should see that video first. This is the pin stack that came out of the Correct Genes lockpicking video. These are the pins that came out of the 5C best core. So you can see there's 7 sets of pins. There's a bunch of spools, and that's what we're here to create a control key from that set of pins. The next step here is to actually measure the pin lengths. You can see I have the code book on top of this little box on the left side, and there's the pins. I've cleaned them with a Kleenex, and then I'm measuring them. So you can see in the calipers I've got a pin there that's between on the chamber 1, 2, 3. It's the middle pin, and it measures 74 thousandths of an inch thick. This is a little more close-up of the pin stack. You can see over on the Sparrow's pinning mat, there's the first pin, which is the key pin, and the middle pin is in the dial calipers, and the third pin is the bottom pin up on the code block under chamber 3. So I start writing down on the yellow notepad to the right of what the actual pin lengths are. This is my notepad for chamber 1, 2, and 3. You can see in chamber 1, the top key pin is a spool pin, and it measures 134 thousandths thick, or 134.5 thousandths, or 134.1345 10 thousandths. The middle pin is a spool. It measures 100 thousandths. The bottom pin is also a spool of 163 thousandths, and I've discarded the spring in the cap. And you can see on chamber 2 there's a spool pin, a middle spool, and a bottom, which is not a spool. Chamber 3 is kind of cut off. The top pin is a key pin, and it's a standard pin. So now that I have all the pins measured and I know exactly what they are in terms of thickness or height, I'm going to take them to my friend's ultrasonic watch cleaner and clean them. This is my friend's ultrasonic watch cleaner. You can see the blue device with the black knob on the top. That's actually an ultrasonic head that you move over to these other containers. So there's 3 containers, and then there's a container, blue one with a screen on it, and a third container behind them. So anyway, this is on the blue ultrasonic cleaner is on the number 3. This is actually the first tank of fluid, and what you're seeing is actually a reflection of the top surface of the fluid where I first put in the pins from the code block. So you can see it's pretty darn black. This is the first rinse. You can see that the fluid is a lot lighter. You're again looking at a reflection, actually seeing the guy's garage door. This is the second rinse, or the third thing in the ultrasonic watch cleaner. You can see their little cages, screen cages, contain sets of pins from each chamber or barrel so they don't get them mixed up. Here's a shot of the pin, all the lock parts after they've been ultrasonic cleaned. And you can see the clean keys and 3 little cages, screen, where a set of pins are in each one. Here's another shot of the cleaned pins. You can see on the one screen, you can actually see a little pin down inside the screen. Here's a shot of the clean parts, the keys, and the core, which I've put in the ultrasonic cleaner and cleaned the core as well. This is the most important shot. These are all the pins after they've been cleaned, put back in the code book. Now if you look along the bottom, you see 1, 2, 3, 4, 5, 6, 7. This is a 7-pin lock. If you look above that, it would be for a 6-pin lock. We have a 7-pin lock. So you can see in chambers 1, 2, 3, 4, 5 on the top are key pins. And these are in nickel silver. Chamber 1 is a spool pin, spool key pin. Chamber 2 is a spool key pin. Chamber 3 is a non-spool key pin. Chamber 4 is a really small key pin spool. And chamber 5 is a non-spool pin. In chambers 6 and 7 are steel pins. And those would actually be in the front of the lock, because best locks are numbered from the tip of the key to the bow. So 7 would be in the front of the lock. So we have 2 sets of steel pins for anti-drill feature in the very front of the lock. Now if you look at the brass pins, like in 1, 2, 3, 4, and 5, the brass colored ones are the other pins above the key pin. In this case, since they were ejected from the bottom, they're actually upside down as they would go in the lock. But those are all brass. You can see 2 spools as bottom pins, which would actually be top pins in chamber 1. In chamber 2, a spool and a top brass pin. 3 has 2 bottom pins. 4 has 2 bottom pins. 5, if you'll notice 5, the brass pins, there's actually a small wafer between the top key pin, and there's actually 2 wafers in there, but there's actually 4 pins in there, so this would indicate a master keyed lock. Chamber 6 also has 4 pins in it, as well as chamber 7. If you notice chamber 7, the second pin down from the steel key pin is also a very thin steel wafer. So this is a master keyed lock. This is an interesting shot because it compares the original code book from correct genes, and now the pins are cleaned up on the right. I've discarded the springs, and there's little caps at the very bottom of the springs. So we threw those away. We've cleaned the pins, and you can see them over on the right as they're all cleaned. So if you look very carefully, you will notice that they all match exactly. Of course, without the springs and the caps, because we threw those away, and we'll replace them when we repin this lock. This is a A2 interchangeable core system. The actual factory size increments. We have the bottom pin length, which of course is the key pin, and then all these master wafers. But the key thing here is that there's code numbers associated with each thickness or length of pin. Now in more detail, you can see like a bottom pin length at the very top of a 0.110 110 thousandths is a code number 0. And you can see 0.222 is a code number 9. So these are very important numbers. And the wafer lengths, you can see the various code numbers for the various thicknesses of the wafers. The depth of cut is actually the depth of cut of the key itself, which is associated with the code number, and the pin length that would be associated with that particular key cut. So this is my written sheet of what I looked at of the keys. You will see the pin length. Look at the top key pin spool is 134 thousandths long, and it's a number 2. The middle spool is 1/10 of an inch or 100 thousandths, and it's a number 8. The bottom is also a spool, and it's 163 thousandths, and it's a number 13. In chamber 2, you see 196. That's a 7. 150 is a 12, and 049 is actually a 4 wafer. In chamber 3, you have a very similar thing. You have a 5, a 6, and a 12. Here's the second page. So if you look at chamber 4, it's a 1, 16, and a 6. Chamber 5, if you take the links and convert them to the codes, it's a 5, 2, 4, and a 12. That has 4 pins in it. And chamber 6 is also 4 pins, a 1, 6, 12, and a 4, and chamber 7 likewise. So this is my third page of that, and you'll notice on the top the operating key should be a 2751511, but it's actually not. If I notice in chamber 5, I have to add a wafer in there, and also in chamber 7 it has a wafer. So when I actually measured the key I had, there in the middle of the page it says with best key gauge, it's a 2751713. So the 7 I said would be a 5, so we're using the wafer in there. And also the same for the 3, which I said should be a 1, but if we use a wafer, that actually lifts it higher, so it's a number 3. And then at the bottom is the control key cuts. You determine that by subtracting 13 from the top pin. We'll explain that in the next slide. So here, this is to decode for a control key. So you measure the top pin and convert to the coded length, which is the number. And you subtract that from 13 and you get the control key bitting. That assumes, of course, that all the pin stacks add up to 23, as in the standard of best. So this is really the tells us everything we need to know. If you look at the top, best 91B 5C core, and note key pins A, barrels 1 through 5 are nickel silver, as we saw. The barrels, all pins in barrels 6 and 7 are all steel. I use the words barrels and chambers interchangeably. All other pins are brass. We saw that when we looked at the pins. Spools is indicated. I marked on there with spools. So if you look down at the very first vertical column, barrel 1, pin 1, so is a 13 on the top, an 8 in the middle, and a 2 is the key pin, which is they're all spools. Barrel 2 is a 4, 12, 7 with a 7 key pin, which is a spool. And I've indicated that they're all nickel silver. That would be on the key pin. So I think I probably marked it up on the top, but I didn't do that right. So we have all the codes there. These are actual code numbers of the pins that are actually I measured that are in the stack. So to make a control key, you take the bottom pin, which in this case is really the top because it's upside down when you actually load it, because the key pins would be where the key is, and you subtract 13 from it, and you come up with the control key bitting. So it's a 0917193. That is the control key bitting. So here, this is very interesting. I've actually flipped the code book around to match the pinning sheet. So you can see in chamber 1, which is actually, now I've flipped it around so that the key pins are on the bottom to match the pinning sheet. So there's a number 13, an 8, and a 2, number 2 key pin. And so you can see them matching what the code, what the pinning sheet shows, so they match up. So that's very interesting. So that's the actual specification of the pins in code numbers. So my next step is shown here on the first sheet. I see the operating shear line is 427 thousandths and the control shear line is 552 thousandths. So I was just checking them. Look at chamber 1, yes, the key pin and the key cut match up to the operating shear line. And then I look at the control shear line with the key pin. The middle pin and the control key cut is a 0, and that brings us to 552 thousandths, which is the control shear line. So I do that for each chamber, just checking and verifying that the control key you can see is circled on the left. So we have a 09471. This is a continuation sheet for chamber 6 and chamber 7. So we have a 9 for the control key and a 3 for the control key. But looking on the bottom, I observed that the key that I actually had was a 275173, but the operating key would be a 2751511. So I'm using the actual little master wafers that are included in the pin stack. This is just another check sheet where I checked that the actual pins that I measured were within the factory specification, just to make sure everything was correct. And I determined that everything was within 15 ten-thousandths or 1.5 thousandths of the factory specification, which was okay. And I did that for both the operating key and the control key. This is just a check. So what we're doing here is we're actually going to cut a control key. This is the Best AD433-2 combinator. It's known as a combinator. This is manufactured by Best to actually cut keys. So here I'm starting to pull down the handle. We're actually going to cut a number 9 cut. You can see the lever next to the dial reads up 5, 6, 7, 8, and it's covering number 9. So that means we're going to make a number 9 cut when we pull the handle all the way down. This was for demonstration purposes. I'm just pulling the handle down, but I want you to understand that this Best combinator actually has a punch and a die, and it actually punches out, cuts a cut in the key, unlike a standard type key machine where you use a cutting wheel that cuts a groove in the key. This one actually punches it out with a die and a punch that cuts the key itself to the correct depth that you set on the dial. Here I think I set it on a 0. This was just for demonstration purposes. This is where I've actually put some pins in the core and capped them. In chambers 1, 2, 3 have the brass cap on it. Chamber 4 has a spring sticking out of it. 5, 6, and 7 are capped with little brass caps. What I'm showing here is that I'm actually testing. I have the key pins in chamber 4 and the spring sticking out, so I actually take my thumb and press down the spring and operate the control key. And as you can see, the control lug is withdrawn. Then I would put in the operating key and make sure that the pins are correct. It works with the control key and the operating key before I cap it. So this is just to show you what I actually do. The capping process we'll get into the next shot. So here we have the core is loaded in this special capping block. You can see in chamber 4, the 4th hole in the middle has a little cap on top. Underneath that is the spring, and the pins are inside the core. The core is pushed into this code block, and you can see the lock on the left and the empty code book on the right. So here is what you call a capping tool, which is this black tool that's in the hole in number 4 sitting on top of the cap. So you take a mallet and you pound on the capping tool, and it puts the cap on the core. So this is the last one to be pinned, last one to be capped. So now we have the core complete, and we've checked it, of course, with the keys and all the chambers one at a time, so we know that the keys work, both the control key and the operating keys, and it's all pinned correctly. So here's a shot of the control core with the control key in it sitting next to the padlock itself. You can see that the lug that holds the core in with the control key is retracted into the core. There's a driver on there that opens rotates the locking mechanism for the padlock, and there's the 2 operating keys that came with the lock. So here I have the core partially inserted into the lock, control key in place, so I can push it into the lock body. Now the core is inserted fully into the lock. We have the control key in position. Now if we withdraw the control key, everything will stay within the lock body. This is to demonstrate that now I have the operating key in the lock, and the lock is unlocked. This is a key retaining lock, so I can't take the key out in this position, but as you can see, the hasp is unlocked. Here I've pulled the core out of the lock body and just laid it there on the pinning mat, and you can see it sitting there. This is a final picture of the lock. You can see the 3 keys, operating key on top, another operating key, the same 2 keys that came with the lock, and now we have a control key, so we can actually take the core out, change the pinning, whatever we want to do. So that's it. I hope you enjoyed this little slideshow presentation. So please leave any comments below, and thank you for watching.